Somehow this is supposed to work out and make sense somehow, because it's a well-accepted theory. So he, from his perspective, has been traveling less than a year. He knows he's been traveling at 0.9 light speed, so he believes that he's traveled less than a 0.9 light years? Where is this guy? And where is this light beam? And where is it? Is it meh? Where is it meh? The thing, man, he fires. And he fires the gun. Yeah, I mean, the spaceship guy is always going to feel that the light is 1 light year ahead of him. If he feels he's been traveling for a year. Which I guess then, if he feels he's been traveling for less than a year, he feels that the light is subsequently less than 1 light year ahead of him. And maybe his less than a light year of distance, from his perspective, plus the less than a light year of distance for the lights, from his perspective what the light is, does that add up to be the same thing as what the gun guy observes when he said, no, because the gun guy should be thinking he's even, no, yeah, I mean, the gun guy should think he should be pretty close, or something, right? So, the guy with the gun, this can go on forever. This video is long enough as it is. I'm just going to keep thinking. The guy with the gun thinks that the light beam is slightly ahead of the spaceship dude, right? And the spaceship dude thinks the light beam has moved the speed of light, and so is, I believe, he thinks it's much further away from him, unless it all adds up somehow that the lesser time should exactly equal the change in distance. Okay, this is a question of how far did the spaceship guy go? Like, if he goes out, Lightning 5, yeah. Like, say he stops. Right? From his perspective, the light is a light year ahead of him. Now he's stopped, right? And let's say he sends out a probe. And let's say, I don't know, there's been some gigantic array of sensors that's been picking up the light as it goes by without interfering with the light or something. And so when the light stops, or after a year's worth of time, gun guy's perspective, the sensors shut down, and so we know how far the light went, and it went 1 light year from the gun guy's perspective. Now, from the gun guy's perspective, the spaceship, now stopped, is 0.1 light years away from the end of until the last activated sensor, right? Like the light got to here, not here within 1 year. Right? So he thinks that this guy is 0.1 light years away. Right? Now the other guy, as time is dilated for him, so he feels that less than a year has gone by. Maybe he's confused about that. Let's just say that his ship has been programmed to stop. And he's like, oh, I thought, it's been less than a year. What are you talking about? So the ship has stopped. He feels that less than a year has gone by. He feels that the light still traveled this whole time at light speed, so it should be a full light year ahead of him. The final activated sensor should still be a full light year ahead of him. Now we can see the paradox pretty clearly. Let's say the guy in the spaceship sends out a little probe to go find the final activated sensor, right? And let's say this probe moves at like 1 mile an hour or whatever ridiculous crap, so that it does not suffer any time dilation effects from anyone's perspective. Alright, the gun guy and the spaceship guy are, from each other's perspective, both standing still, and this probe is moving about 1 mile an hour from both of their perspectives. Alright? Now, what's the probe going to find? From one perspective, see, this is a weird thing. Like, you can kind of see how things would change, how time would change when you go really fast, and then you stop, and then, like, oh, you know, this thing is different in terms of, like, age, in terms of how much time has gone by for each of us. The much harder thing is to see, is to reconcile other problems besides that. Like the age, you can kind of get, even though I still don't know how the universe distinguishes one twin from another. You know? I mean, how does the universe even, like, what if the two twins both fired off at half the speed of light in two directions, and then turned around and came back? Surely they would both suffer the same dilation effects, even though each of them sees the other leaving and coming at nearly the speed of light. How the freak does that happen? Are they old? Are they young? Are they the same age? Are they... Okay, so when this discrepancy of time, I think, in the Gunga experiment, it leads to a discrepancy of distance. And this probe is going to go out and count the number of sensor thingies it goes by, you know. And now no one's moving at the speed of light. Everything should be normal. Everything should be, you know, like with the twins paradox, there's no like, oh wait, is the twin here with me or is he still out there? Like, oh, he's still with me. That much is apparently obvious. But with this thing, okay, how much distance did I travel compared to the light beam? From the gun guy's perspective, 0.9 the speed of light, full the speed of light, 1 light year, 0.1 light year difference. From the spaceship guy's perspective, 0.9 the speed of light, like he knows that abstractly or something, but then the speed of light, this light is still going the speed of light from his perspective. Okay. And so the light, wherever it is, should be 1 light year ahead of him. Is it 0.1 light years ahead of him, or is it 1 full light year ahead of him? What's the probe going to find? I have no freaking idea. I think the probe, in a metaphorical sense, is going to find that the universe is very, very weird. Yeah.